Assalamu alaikum. In this video, we will discuss the production and the properties of electromagnetic waves. The presence of electromagnetic waves was first predicted by Maxwell, which was later confirmed by its production in lab by a scientist, namely Hertz, in the year 1888. In this video, we will discuss the method followed by him to produce electromagnetic wave in lab. Let's do it. First, we'll discuss the production of electromagnetic waves. Production of electromagnetic wave. In short form, I write it as EMW. Here, EMW stands for electromagnetic waves. Okay. I told you it was confirmed in the year 1888 by Hertz. Okay. So, the experimental setup that he used for the production of EMF is comprising of two electrodes which were in the shape of spheres. This is one electrode. This is another electrode. These electrodes were connected to metallic spheres whose outer surface is highly polished. They were two metal spheres whose outer surface is highly polished, were connected to these electrodes with the help of thick copper wires, and in turn these electrodes were connected to an induction coil. So, what is this induction coil? Induction coil is actually a device used for the production of high voltage. This is capable of producing voltage of the order of 15 to 20,000 volt. Induction coil. It consists of large number of enameled copper wire turns, okay, and produces high voltage. Fine. So, to one such induction coil, this setup is connected. Now we know very well we are surrounded by air. In the similar way, even this setup is surrounded by air. The air which is present in the gap between these two spheres, which are at a high voltage, gets ionized. Here, the air which is present here, the surrounding gets ionized, and they produce spark due to discharge of these ions. Now, before going ahead, let me tell you what is this ion. So, there are two types of charges which we have learned earlier. One is a positive charge and one is a negative charge. In an atom, almost everything in this universe is made of atom. Atoms have electrons, protons and neutrons. Correctly speaking, they have electrons revolving around the nucleus. Now, within the nucleus, if you see, they consist of protons carrying positive charge and electrically neutral neutrons. Okay, here protons provide a positive charge to the nucleus and electron provides a negative charge. Okay, and here the number of electrons and protons present in the atom are equal. So, an atom always remain neutral. Now, due to some reason, by the supply of high voltage or by some reason, if we disturb this equality or this neutrality, what happens? The atom either turns into a positive ion or it becomes a negatively charged ion. Okay. So suppose I have an atom to which I supply an electron. If I do so, what will happen? The quantity of negative charge of the atom will increase compared to that of a positive charge. So that atom turns into a negative ion. The similar way, suppose if I remove an electron or few electrons from an atom, in such case, the negative charge of that atom will reduce and it will become positive ion. So this phenomena of conversion of an atom into ion is called as ionization. So the molecules of air present around this metal spheres which are connected to the induction coil now gets ionized by this process, right? So there will be accumulation of large number of positive and negative ions around these spheres. Now here, suppose a positive charge, a positive ion comes near a negative ion, they gets neutralized after combination. So this is called as discharge. During the discharge, a spark is formed. Okay, a spark is formed here, something like this. This spark. Now here, what he did, he placed a loop now at some distance from this setup. That loop also had two spheres separate from each other. The loop, okay, fine. Now whenever a spark is observed here, the same thing is seen on this setup as well. Now he named this setup as receiver and this one as transmitter. So I told you, whenever a spark is observed here, on the receiver a spark appears. This clearly shows that energy has transferred from transmitter to the receiver in the form of wave, and that wave is nothing but electromagnetic wave. Now after that, he rotated the receiver to an angle of 90 degree. An angle of 90 degree, like this. It was rotated to an angle of 90 degree. What was done when the receiver was rotated to an angle of 90 degree, no spark was found between this gap, in this gap. Okay, so this clearly shows that the wave generated here is nothing but a transverse wave. Transverse wave. What is this transverse wave? Well, in 11th standard we have studied about two types of waves. One is a longitudinal wave, another one is a transverse wave. In a transverse wave, the oscillation is found to be propagating. The oscillation is found to be perpendicular to the direction of propagation of the wave. Okay, well, this is the direction of oscillation, and the wave moves just perpendicular to it. Means we call such wave as transverse wave. If the oscillation of the particles and the propagation both act in the same direction, means we call such wave as longitudinal wave. Okay, so here this experiment shows the production of electromagnetic wave, and apart from that, it confirms that electromagnetic wave is a kind of transverse wave. I hope you understood. Now let's go ahead. Now I'll discuss a few properties of electromagnetic waves. Properties of electromagnetic waves. First, they travel in a straight line. They travel in a straight line. Straight line with the velocity of light. They travel with the velocity of light. We know light travels with velocity equal to 3 into 10 power 8 meter per second, and this is found to be equal to the velocity of electromagnetic wave. Even electromagnetic wave travels the same velocity. Okay, and here the velocity of electromagnetic wave is given as 1 upon root of epsilon naught mu naught. This mu naught multiplied with the epsilon naught. Here epsilon naught represents the permittivity of free space or vacuum, and the mu naught represents the permeability of free space or vacuum. So this is this equation provides us the velocity of electromagnetic wave. Okay. Next, I told you earlier, electromagnetic wave is a non-mechanical wave. Non-mechanical wave. No. Sound is a mechanical wave. It requires a medium to travel. But electromagnetic wave is a non-mechanical wave, so it doesn't require any medium to travel. No, it is a non-mechanical wave. So for this reason, it doesn't require a medium. Doesn't require a medium. To travel. Okay. So this is another property of a electromagnetic wave. The next, electromagnetic waves have no charge. They have no charge. Hence, not deflected by electric field and magnetic field. Hence, not deflected by electric field and magnetic field. I'll just remember this. Now, another property of an electromagnetic wave is electromagnetic waves undergo reflection, refraction, polarization, diffraction. These are some of the properties of electromagnetic waves. Electromagnetic wave shows the reflection, refraction, diffraction, polarization, just similar to that of light. So light, currently speaking, is nothing but an example of electromagnetic wave. If you know the properties of light, you can easily write the properties of electromagnetic wave as well. So next, one more thing I do want to tell you about the speed of electromagnetic wave. Electromagnetic wave travel with lesser speed in a medium compared to vacuum. The velocity of electromagnetic wave is less in a medium compared to compared to that of a vacuum or free space. Okay, then another property is, so here before I go, let me read one thing. Suppose V is the velocity of an electromagnetic wave in a medium, then it is found to be lesser than the velocity of electromagnetic wave in a vacuum, no, which is represented letter C. Clear? Like other waves, electromagnetic waves also possess energy, linear momentum and angular momentum. Electromagnetic waves possess energy, linear momentum and angular momentum. Right? So these are some of the properties of electromagnetic waves. So here I do want to elaborate this point. As I told you, the velocity of electromagnetic wave is less in a medium. Now suppose I have a medium whose refractive index is given by this 1 upon root of mu epsilon the whole divided by 1 upon root of mu naught epsilon naught. Okay, this represents the velocity of the electromagnetic wave in the medium, and this represents the velocity of electromagnetic wave in vacuum or in free space. Okay, that is V by C. V upon C. Now this is the ratio of these two gives us refractive index. It tells us to what extent a wave to what extent a wave refract in a medium when it enters from another medium. Okay, or in simple way, the measure of bending of a wave when it travels from one medium to another medium is referred as refractive index. Understand? Now, here. And next thing I forgot to mention, here I told you mu stands for permeability and epsilon stands for permittivity. What is this? In the first and third chapter we have studied about this. So here permeability means ability of magnetic field to pass through, or ability of some material to allow the magnetic field through it is called as permeability. And permittivity is to what extent electric field passes through some medium is referred as permittivity. Okay. Now here this can be expanded as, okay, let me write this with now, 1 upon root of mu epsilon is multiplied with, when it is taken up, no, it is in denominator, when it is taken to numerator, no, this reciprocal will disappear and we will get this. When now this can be written as whole root of mu naught epsilon naught divided by mu epsilon. Okay, this ratio can be referred as, okay, here I will make one change to this. Instead of mu, I'll take En for refractive index. Because both sides we cannot use the same term. Here, this ratio can be written as mu r epsilon r. Here, mu r and epsilon r stands for relative permeability and relative permittivity. Clear? I hope the video is useful. If you have any kind of doubt relevant to the topic, kindly put a question in the comment section. Thanks for watching.